Hello friends, welcome back to my channel. So in this video, we will be learning what is AI really though. So this will be very helpful for explaining AI in interviews. So first let's look at the interview ready answer. So, artificial intelligence is the field of building systems that perform tasks normally requiring human intelligence, such as perception, reasoning, language understanding, prediction, and decision making. So, AI is nothing but a system that can perform tasks which requires human intelligence. Okay, so if I want to make a if I design a system that can make decisions like a human, so that is an AI. If it can predict like a human. For example, if a system is able to identify, okay, this is a cat and this is a dog after seeing an image of the animal, so that is an AI for you. So whatever task the requires human intelligence, if that task can be performed by any machine or any system, that is called AI. So it is not any magic. It is just engineering applied to tasks that used to need a human brain. Okay. So you are just putting your human intelligence into a machine using AI. So I hope the definition is clear. It is the field of building system that perform tasks which normally requires human intelligence. So AI is an umbrella. Must have listened to various terms related to AI. So AI is an umbrella and it includes various terms. AI is not a single thing. It is an umbrella. So AI is not just machine learning. AI is both rule based as well as machine learning. So if you write various if else logics, suppose there is a system that has various if else logics, like if the user has fever more than this, if the user has cold, if the user has cough, so suggest you the user that it is a flu. So there are very many complicated rules, many complicated if else conditions. That is also an AI. Historically, that was also called an AI. So rule based systems, complex if else logic is also artificial intelligence. Now the another type of AI is machine learning, where you are not giving various if else conditions, like if the user has this, if the user has that. No, you are giving lots of data to the system. So you are not writing if an email contains this, then mark this email as spam, otherwise it's a non-spam email. You are training your system with lots of spam emails as well as non-spam emails. Now, if a new email comes, the system is able to predict whether that new email is a spam email or a non-spam email based on the training that you have provided. Same like humans, right? If I see a lot of spam and non-spam emails, I know if a new email comes, oh, this is a spam email. So you are giving that intelligence to the system. Okay, so you are not explicitly writing various rules, but you are just training on the data. And now the AI, now the system can itself predict the future values. So machine learning is a model that learns patterns from data instead of rules. So you are not providing explicit rules, but you are providing lots and lots of data, and machine is learning from that data and is able to make decisions based on that data. Now deep neural network or new neural network. Basically, this is one of machine learning algorithms. There are various machine learning algorithms, linear regression, and lots of algorithms. So the most famous algorithm is neural network. And if the neural network has many layers, that is called deep neural network. So neural network is basically it is similar to the biological neurons in our brain. So that has been, replicated in the systems. So there are various layers that helps in learning from the data. So it will, for example, you have supplied various images of cats, and so it learns that the edges, the texture, everything it learns, and then finally it can predict whether an image is of a cat or not. Okay, so it is a algorithm, learning algorithm. And if neural networks are able to solve complex problems having many, using many layers, that is deep neural networks. So that is many layered MLs. And there are various application of deep neural networks like computer vision, natural language processing, and generative models. Okay, so this is the brain behind all the applications of AI, most popular applications of AI. So computer vision is an application of AI that mostly uses deep neural networks. So anything, basically it is trained on images and videos. So machines that can actually see. So for example, our face recognition, our face lock in our phones, that is an application of computer vision. The system can identify, okay, it's me who is logging into the phone. If tumors, suppose the machine is trained with lots of X-rays, lots of CT scans. So machine is able to identify, okay, this CT scan, this X-ray indicates some problem, some tumor. Traffic signs, for example, for self-driving cars. So they can identify, there's a video camera that captures lots of images, and the system can identify, okay, this is a traffic signal which says stop. So I have to just apply brake and stop here. So computer vision is a application of AI which helps recognizing images and videos and perform various tasks based on that. Natural language processing, basically, these are machines that read, summarize, translate, and chat. For example, our chat GPT, right? So we can have a good conversation with chat GPT. It can help you summarize any data. So also like Google Translate, that can translate your data into any language. So anything that deals with, text. So that is natural language processing. Generative models or generative AI, it is a new field of AI that helps you generate text, images, videos, audios. So LLM chat GPT, it also generates text for you. It can also generate images for you. That is your generative AI or generative model. So as you see, AI is an umbrella, and all this comes under AI. AI has two fields: rule-based system, that was historical. Historically, all the very complex rule-based systems are used to call AI. Now we have machine learning, which learns from data. You don't specify rules as such, but you train your machine with lots of data, and it can make decision based on those data. And there are various algorithms of machine learning. One of the algorithm is deep neural networks. Okay, and there are various applications that uses deep neural networks algorithm of machine learning, which are computer vision, where machines can see, machine can understand images and videos. Natural language processing, machine that can read, summarize, translate, and chat. Generative AI, generative models, machine that can generate something for you, can generate text, images, videos, audios for you. So this is your big picture of AI. So modern AI, it mixes two minds. Okay. Deterministic and probabilistic. So earlier it was deterministic, rules you can trust, right? For example, 2 plus 2, it is always 4. You specify an input 2 plus 2, there's a fixed logic of adding, and then you have exact output 4. If you ask tomorrow, day after tomorrow, after 5 years, the answer will always be 4. So how will you test that? You test that this is my expected output. If my actual output matches expected output, then it's a pass. Otherwise, it's a fail. So all your APIs, workflows, permission, data rules, all these are deterministic. If the API gives 200 status code, then it is a pass. Otherwise, it is a fail. But probabilistic, it is a patterns with a chance. For example, you give the input, how do I reset my password? You give that to an AI model. So it is not necessary that every time the answer will be same. There could be many replies, and the language of the reply will be different every time. So you need a statistical, semantic, and risk-based evaluation. Statistical in the sense, suppose I have to test it with a large data set. I had tested it with 50, 50 times. And if every time, for example, out of 50, 45 times I am getting a good answer, it is able to explain how can I reset my password. But maybe three times it is something else. It is telling me about some tree, like it is completely off topic. So that is called hallucination. Now the model is hallucinating. It is not answering what I asked. It is just generating random text. So 3% you can say maybe hallucinating. 1% maybe it suggested me something toxic. So like something that is not appropriate. So that could be the case. So you have to see the stats. Now semantic means the meaning should be same every time. If I ask this question, how do I reset my password? The meaning should be same every time. And you have to see the risk. Okay, maybe the answer is not good enough, but it does answer your query. So that is okay. So you can't mark it as complete fail. So you have to see various factors like relevance. So you asked a question and the answer should be relevant to the query that you have asked. It should answer the query that you have asked. So the answer should be relevant. Groundedness. It should be based on the factual information. Like the reset password step should be how as I have defined. You have to click here, then you have to enter your email, and then a mail will be sent with the reset link. So it should be grounded with the information that you have provided. You cannot suggest any random steps that does not fit into my website or my app. Okay, so the answer should be grounded with the factual information, and it should be safe. It should not suggest, it should not reveal any password or something like that. It should not reveal any security related information. So the answer should be safe and it should be consistent. Even if I ask the question differently, how can I reset my password? Can you tell me the steps how I can reset my password? All these should be produce same answer. Same answer means the meaning should be same, the steps should be same, the language can be different. So the answer should be consistent. But if it is not producing the answer correctly, if I have I cannot give a exact string, exact text that it should produce, because the text will be different every time. But I can define some threshold. Okay, if the meaning of the answer is this much, if it is, if it is appropriate enough, if it matches 80%, then pass it. Otherwise, if it drifts completely, if it is answering something else, then it's a fail. Okay, so it is not exact pass or fail. It is, the answer will be different every time. So you have to provide a threshold. If it is matches, if it is within that threshold, then it's a pass. Otherwise, it's a fail. So how a QA pro can attack it? For deterministic part and for probabilistic parts. So for deterministic part, you define exact assertions, the kind of test that you have been writing. So you have to define, okay, for deterministic part, you have to write test like, okay, the status code should be 200, the API should return this information, this should be the data. After logging in, I should see this information. These are deterministic and this will be same every time. For probabilistic part, that is your AI part, you have to define some threshold. Is it right or is it good enough? Okay, so how relevant the answer is for the query. Is the answer grounded in the factual information, in the data that I have trained it with? Is the answer safe? Is it consistent? Every time if I ask it, if the answer is consistent, how much time it takes to answer? So all this you have to consider. Mostly you use another LLM to check whether the answer is relevant or not, whether it is safe or not. So we will learn about this, how we can evaluate it. There are various tools also like Arise, Vellum, and you can write your own scripts also to evaluate LLM answers. But the answer is not simple assertion like, okay, it should contain this, the answer should match this. The answer will not be same every time. The output will not be same every time. So you cannot put exact assertions like you can put for the deterministic part. So you have to identify which component is which, and then you have to write your test accordingly. Let's take an example. Suppose a customer type a question, what is my balance and can I transfer $500 to rent? So first there will be deterministic part. So there will be APIs that will identify who is asking this question. Is he or she a valid user or not? Then after authenticating and authorizing, it will fetch the balance information. What is the balance? There will be, fixed deterministic APIs. It will check what is the transfer limit, what is the per day transfer limit of this user. So there are hard rules. So here you will have exact outputs. Now after making all these API calls, so then LLM, after making these API calls, then you will have the LLM part, or you can say the probabilistic part. Now you have all these information. Now you have to create a friendly grounded reply based on the information. You have to create a reply which could be your balance is 1240, I have queued a 500 transfer, confirm to proceed. You have to got all the information of recipient, everything you got from deterministic API calls. Then LLM produces a friendly answer. LLM is nothing but large language model, that is your AI, generative AI, that creates an answer. So now this answer could be different. The friendly safe answer that you have that have been provided, it's not, it won't be exactly same every time. So right now it is your balance is this, so it could be 1240 is the balance that I have retrieved, or anything, the text could be different. So here, for the fourth step, you will have probabilistic checks, whether the answer is relevant, whether the answer is grounded, safe, everything, all those checks will be there. And for the deterministic part, that is step two, you will have your deterministic assertion. You will have the get API call, and you will check if the balance is correct or not, if the transfer limit is correct or not. So all this, whether the user is able to be authenticated, if valid user is calling the API, all this, those deterministic checks will be there. And the end will be your probabilistic check. Okay, so it will be a combination of two testing strategies. I hope you got the point. So you will have deterministic assertion where the output will be same every time, and you will have probabilistic assertions too where the output will be different every time. So you will have both type of assertion and nothing but checks. You will have both types of checks. Let's look at the three classic mistakes to avoid. Treating every automation rule is AI. So this is a marketing, false marketing. There is some logic like if the priority of this bug is high, route it to team A. If the priority is low, route it to team B. This is a very simple automation. Like this is a very simple logic. It is not AI. So you will have very simple checks for that, very simple test for that. So this is not AI. Uh, as we have discussed, mostly in modern times, AI is where you are learning from data, where you are not explicitly telling the rules, but the rules are being learned by AI itself. You are just giving the data. Or, as you know, the rule based AI, these are very complex logics, like the patient has this. So, very simple automation rules cannot be treated as AI. And assuming AI always means machine learning. As we have seen, AI is rule based as well as machine learning. Okay. So, and it can be both rule based plus machine learning, as we have seen in our previous examples, right? This is banking chatbot example. Also, AI is not machine learning, as we have seen. AI is rule based and machine learning, and machine learning also has various algorithms. And based on those algorithms, one of the algorithm is neural network, deep neural network. There are various applications like natural language processing, computer vision, generative AI. Okay. So AI is the umbrella. AI has rule based and machine learning. Machine learning has various algorithm including deep learning. And then there are various applications of AI including Gen AI, generative AI. And the third mistake is testing probabilistic output with exact string match. So since the answer will be different every time, you cannot test it with exact string match. An LLM might say sure, of course, instead of yes, but that does not mean that the answer is incorrect. It is just it is the semantically it is correct. The meaning is same. It's just that the text is different. So exact assertions will fail every release and it will not tell you anything real. So you have to use semantic plus threshold based checks. If it is within this threshold, then it is correct. If the meaning is within this threshold. Okay. So let's look at the likely follow-up questions that you can get in interviews. How is AI different from automation? We have already seen that AI learns from patterns. AI is not rule-based. So automation is fixed. You have defined some rule like the ticket system, priority high, assign it to team A. If priority is low, then assign it to team B. But AI is like you train the model with various emails, spam and non-spam email, then AI is able to identify whether a new email is spam or not. Okay. So automation is fixed, AI is adaptive. Automation has rules, AI learn from the patterns. What is narrow AI? Narrow AI is basically AI that is designed for a specific task or specific related task. For example, ChatGPT, it is designed for answering our queries, answering or helping us generate code, text, summary, image. Okay, so it is designed for a certain task. But if you ask ChatGPT to drive a car, it won't be able to do that because it is designed for another task. Self-driving cars are different. Self-driving cars cannot, generate images for you. So every AI is designed for different tasks. Google Translate is just designed for translating your task. So the every AI is designed for certain task that is called narrow AI. Then The other one is AGI, artificial general intelligence, that can do everything what a human can do. Like it can drive a car, it can generate text images, it can do everything. That does not exist yet. Right now, we only have narrow AI. So, why is AI, the third one is why is AI different from traditional testing? As we have discussed, traditional testing is deterministic assertions. So, you know the expected output, you just compare whether your actual output is equivalent to expected output or not. AI testing is different. You don't know the expected output, but you test it with threshold. The expected output should be this, but it might not be exactly, the text might not be exactly same. So you have probabilistic thresholds here. Semantically, it should mean the same. It should be safe and secure. It should be relevant to what the user asked. It should meet these 90-80% threshold criteria. Then it's a pass. So, if you are asked AI, there are three moves to nail the answer every time. First, you open your answer with a concise definition. AI built system that perform tasks normally requiring human intelligence. Confident, crisp, done. Then add one practical example, like the banking chatbot example that we gave. So that a real example and split it, you add a real example and split the deterministic and probabilistic part there, and then as a QA you can, you know, tell how you can evaluate it. For deterministic part, include exact assertions for the rules, and for the probabilistic part you can use quality threshold for the model. So that's it. You tell the definition, give an example, tell how will you validate, and you will be hired. Now you can be the person who tests the AI and not the one who is afraid of it. So if you like this video, then please make sure to subscribe to my channel. Thank you for watching.